ladies and gentlemen. This is KB the Math G here, and I'm here to do what will be the 200th YouTube video. Of course, this video 100, I didn't do anything, but I included my wife, and she's the one who kind of, she allows me to do this. Actually, I can do it if I want to, but she has my support, and I have hers. And of course, there was a couple of times when I was applying for a job, and I was doing very short videos for that. So really, I get 3 more videos in. Actually, after the 200th video, about the 203rd video, I will have exactly 200 AP Calculus based videos. Isn't that something? And what I'm doing here with this stretch, this is the last stretch of AP Calculus I'm going to do. That doesn't mean I'm going to be through videoing. I'm going to be doing ACT, SAT questions, and probably getting into college algebra, and maybe some algebra 2, some geometry, maybe some trigonometry, probably for sure, a little bit of pre-calculus, whatever I need to do. But I'm going to be through, because after so long of doing calculus problems, they kind of start overlapping. There may be a little bit of a twist, but all in all, you still have the same type of problem. So let's look at this. This is my 200th video, and by the way, I've tried to do this before with a different problem, and I realized that it wasn't the problem that I had anticipated doing. I did it incorrectly, and I looked at that and I realized, well, let's change it up. So I did. So this should work for us here. What we're dealing with, this is the big 3 in AP Calculus. We're on continuity. It's probably about the 3rd or 4th lesson dealing with the big 3. The big 3 is limit, derivative, and integration. If you know the idea at least behind that there are big 3, the big 3, that gives you a kind of a heads up, gives you a little bit of a you get a little bit ahead of the game, a little bit, if you will, and so that's kind of where we're at right here. So we're dealing with continuity, and there are 3 rules of continuity. Let's talk about them, and I'm going to try to keep everything on this side of the board. I can flip this board over and look at the other side, or I can flip it over and work on the other side if we have to. But let's look at the 3 rules. Now, what we got to look at is that you got a parabola here, and this is a linear equation here. Okay, and so what we're looking at when we talk about continuity. So you got a parabola here, and I noticed that somewhere along here the line the line goes on, and the parabola goes on and on. But this is kind of the idea behind this. Is this, let's say this is 2 right here. Is this a gap here? Okay. Is it connected? If it is connected, it is continuous at x equals 2. All right. That's what we want to find out. That doesn't really say much about our 3 rules. Let's talk about the 3 rules. Okay. Rule number 1. All right, let's look at it. This is a test. Actually, you're running a test on it. Test number 1. So we're just going to say test. 3 tests. Number 1. Does LFET, in our case, we're looking at 2. This is the main one we're looking at. Does LFET A or LFET 2 exist? Okay, so in other words, what we're saying here, at 2, is there a solid point somewhere at 2? It could be up down here, it could be up here, just somewhere. Is there a point right here, LFET 2? Let's say this is 5, I don't know. Yeah, if it is, then it exists, okay? That doesn't prove continuity yet, because all we got is 1 point, okay? And then you ask yourself a question at this point, and you'll see what I'm talking about when we do this. Does the limit exist? Does the limit as x approaches, let's say the limit as x approaches 2, f at x exists? It could at x equals 2. Alright, does the limit exist? And we'll have to talk about the left hand and the right hand limit. I'll show you what I'm talking about there. Just kind of give you an idea. Okay, so x, y, you got a graph here. Here's a point right here. Okay, so does this point at f at 2 exist? Does the limit, and this is so dark, so light. Sorry about that. If we look at this limit from the left, does it exist here? If we look at the limit from the right, does it exist here? And if all this equals, if 1 equals 2, then we have continuity. If it does not, then we don't. And it may not be that even the limit exists. Okay, so if something fails anywhere, then number 3, if it doesn't fail, we go to number 3. If it does not fail, then we say, does f at 2, let's put it down here, does f at 2 equal the limit as x approaches to f at x? Does that exist? If this, all 3 of these must stand for this to be continuity at x equals some number. Okay, it could be continuous at other numbers, but not continuous at this number. You have to understand that as well. Okay, so kind of keep that in mind as we look at this. So we're going to look at these 3 rules right here, and we're just going to kind of go with this. Let's start with the first one. All right. Does f at 2 exist? F at 2. Well, you got a piecewise function. F at x is both of these. Yeah, that's called a piecewise. Anytime you see more than one function of f, it's all called f, but it's 2 different functions, but still called f. This is called a piecewise function. Do these 2 pieces, does this line come up, when this curve comes up like this, does the line meet at this point right here at x equals 2? If it doesn't meet, okay, say the line goes here and the curve goes up here like this, they don't meet, they don't touch, this is going out this way somewhere, well, alright, okay, does not exist. So there's all kinds of scenarios here that we could look at. We don't have time to look at all of them here. So we're just going to probably just do this one problem. I want to come back and do another one, and let's just see if this one works. Does this curve, which is like this, does this curve meet this line? This line's slanted this, well, it is slanted to the left. Anyway, alright, the one over here, does the curve, okay, slanted to your left, okay. Is it going to meet here? Okay, does it meet somewhere at 2? Will they meet there? Will they intersect there? Let's find out. So f at 2. How did I find f at 2? Look over here. This one has no equal to sign. It's greater than 2. We don't want that one. We want the one that, I know it says less than, but also it says equal to. This is the function we're going to use when we see an equal to. They can't both be equal to. One of them's going to be equal to. You use this one. We cannot use this one because there's no equal to sign here. Let's use this. F at 2 then. F at 2 does equal to 2 squared minus 3, which is 4 minus 3. is 1. Alright? And I do think I have that. Oh, it was x squared minus 3. Yeah, that's right. Alright, so yes, this is true. F at 2 does exist. The answer is 1. The y value is 1. So when you plug in 2, you get 1. So 2, 1. But 1, you got an answer here. Yes, it does exist. Okay, it may be that if it does not exist, we're done. No continuity. Okay, if 1 fails, stop. You don't have to do 2 and 3 because number 1 failed. But since 1 passed, we got to go to number 2 now. So let's put off somewhere to the side. Oh, I don't know where to put it. F at 2 equals 1. So yes, F at 2 equals 1. F at 2 equals 1. Yes, that is a part, number 1. So that, yeah, F at 2 does exist. Alright, now the second part here, does the limit exist? Now, when you check the limit, you got to check the limit from the left side and the limit from the right side. This is where both of these pieces are in play. The left side is where it's less than. The right side is where it's greater than. Oh yeah. And even though it says approaching 2, you still put 2 in both equations. So let's look at the left side. The limit as x approaches 2 from the left. The left is a negative sign always. Not negative 2, it's 2 from the left. Okay? F at x is equal to, wow, which one we're doing from the left? This is less than, this is greater than. Less than is to the left. Greater than is to the right. Okay, so we're going to check this one out. So again, we already checked it a while ago, did we not? 2 squared. Oh, these pens. I'm going to have to just throw all these away and get some fresh pens. Let's try red. How about that? 2 squared minus 3. 2 squared minus 3. 4, oh, what? Actually, I did it wrong. You don't do that. You got to write the word limit. Limit as x approaches 2 from the left. And this, negative 1. 2 from the left. So, now, 2 squared minus 3. Alright, that right there is equal to the limit as x approaches 2 from the left. I don't know why I want to put a negative 1 there. 2 from the left. 4 minus 3 is 1. 1, which is just 1. So whatever this number is inside here, as x approaches 2 from the left, the answer is 1. You just write down 1. So this limit is equal to 1. Now, look so far. The left side of the F at 2 rather, the first part is 1. The second part, as far as the left side is concerned, reaches 1. We've got one more test to make, and that's from the right side. Okay, let me erase this because I want to try to put it all right here. Now, I'm sorry I'm having to erase this, but I just want to try to keep it all on one side of the board. Now we're checking the limit as x approaches 2 from the right. It's going to be a plus sign. That's greater than. We're going to use this one. So 5. Oh, I don't put limit. The limit as x approaches 2 from the right 5 minus 2 times 2. 5 minus, remember you do the multiplication first. Don't do 5 minus 2. Get 3, and 3 times 2 is 6. That's pre-calculus mistakes. I mean pre-algebra rather. Okay? We don't make those mistakes in calculus. 2 times 2 is 4. 5 minus 4 is 1. So the limit as x approaches 2 from the right is 1. So that equals 1. Okay? This result is inside here. So when we get to 1, we just put equal to 1 there. Now look. Both the left limit and the right limit are the same. If one of these limits, say it's 2 here, if one of these two limits are different, stop. You're done. No continuity. You've got to match here and you've got to match here. So what? You've got to get a match for the left and the right. Okay, I know I changed it there. The left and the right both have to be the same. Now, since this is equal to 1, we're really done with our test. Because look at this. F at 2 exists. The limit does exist. The limit would not exist if these two numbers are different. Okay, one's going this way and one's going above it or below it. At this number 2. It's got a gap there. There's no gap here. They link together. Now, what we're going to say, does F at 2, which is 1, and by the way, what we do with this, we say the limit to the left equals the limit to the right. What we say about this, we say then, number 2, the limit as x approaches 2, no plus sign, no negative sign after this, f at x is equal to 1. There's your second test. So now number 3. Number 3, f at 2 equals the limit as x approaches 2, f at x. What does it equal to? It equals 1. Both of them equal 1. Alright? So therefore, this is correct. The limit, that answer is 1. This answer is 1. So if both of them being 1, 1 equals 1, doesn't it? So therefore, we need to make a conclusion. This is great. You got all 3 parts going for you now. Okay. Now, I really need to. I want to say it this way. I want to write it straight out. Okay. F at 2 equals the limit as x approaches to f at x. All this equals 1. So now, therefore, this is a triangle of dots here. Therefore, f is continuous. F, you are dealing with F, is continuous at what x? X equals what? X equals 2. That's what you must say. You get this far, you want to get all the points, you need to say that right there. Don't put this down and you're not able to come up with a conclusion, yes or no. Well, there's the proof here. Yes, I see that. You're going to get points for that, but you're going to get one more point for saying F is continuous at x equals 2. Okay? You can probably imagine what my next problem would look like when we do the next one. The 201st video is probably not going to work, right? But I do want to show you why it's not going to work. This is a lot to take in, okay? Does F at 2 exist? Which one are you going to try? Ooh, which one? The one's got the equal sign. If this had the equal sign, this one would not have the equal sign. If this had the equal sign, you try this one. Okay? This one has the equal sign, so I'm working on this one. The answer was 1. The limit from the left equals the limit on the right. Notice I don't have a plus or a negative sign here, a negative or a plus. I just say, well, the limit as x approaches 2 is equal to 1. Notice that. Match, match. This is true. F is continuous at x equals 2. Graphically, I've already looked at it. It is doing, I don't know where, -3. It's going to move something like this at -3. And this one here, here at greater than 2. Oh, I meant from the right. Yes, okay. It's somewhere going up through here, but this is 2 here. Okay, now it is going down. That's 1, by the way. That's 1. And then this one is going to go. I should probably put it a little bit lower down. Okay, as this is 1 right here. That's the y value. And then this graph is going this way like this, piecewise. The reason why I know this line goes on, but we're looking at the right of 2. This is to the right of 2. This is all to the left of 2. All of this is the function of f. Okay, piecewise. This parabola has to stop at 2. This line has to begin at 2 and keep going. Okay, you got me? So this right here is what it looks like right there. Okay. It's got a slope of -2. Alright. I probably should have it a little steeper than that. But anyway, that's the idea. It's continuous at that point. Okay. This is KP, the math G. Just want you to see. We're looking at the big 3. Alright? And I love doing this because we need to see this. You get this, I promise you. Boys and ladies and gentlemen, if you get this right now and you're studying it and trying to absorb it. I know it's a lot to absorb, but if you can get it and look at it and study it, you're going to be ahead of the game before school starts. Okay? If school starts in August, we still got a few days left to look at all of this. Boy, oh boy, will you be on top. I'm not going to be able to show everything, but I'll be able to show the main parts, okay? KP the Math G signing off. Ladies and gentlemen, if you haven't subscribed, please do so. If you want to make a comment, please do so. If you make a negative comment, tell me what's wrong so I can do better. I like positive ones. We all like positive ones, don't we? And if you want to hit that like button, please do so. If you don't do any of those, subscribe or make a comment or hit the like button. It's about me. It's not about me, it's about you. Not about me. I meant to say not about me. I don't want glory from this. I want you to get this though. That's what I want. Okay, ladies and gentlemen, KP the Math G signing off. You ladies and gentlemen have a great, great day. I need to clap a little louder. Here we go. Let's try it again. Wow. Oh, I'm not going to clap anymore. That one stung.
Bye.